In this problem, we want to write a formula for an exponential function that passes through 2 points. So I typically tell my students that anytime you're asked to write a formula and you know that that function is exponential, you're going to immediately think of the general equation y is equal to a times b to the x, or in this class, we typically use the notation f of t, which is the same thing as y, is equal to a times b to the t, where t is the same thing as x. And here, a represents the initial value, or that's the same thing as the y-intercept. And b represents your growth, or it could be a decay factor, depending on if the function is increasing or decreasing. So to figure out if our function is increasing or decreasing, I'm going to just make a quick sketch of the 2 points to see if this exponential function is increasing or decreasing. So my graph here is not drawn to scale by any means, but this is just to give us a general idea. So -1, comma 5/4, that's our first point there. And our second point is 2, comma 80. So again, not drawn to scale. And then if I connect these 2 points with a curve, and I'm going to connect it with a curve because I know I have an exponential function, we can see that this function is increasing. So because it's increasing, we're going to be looking for a growth factor. So recall that a growth factor, b, when it's a growth factor, we always have 1 plus r, where r is your percent rate of increase, okay? And then on this graph here, we can also see this marking here, which is going to be A. So that represents A, which is our y-intercept, where the graph crosses the y-axis. Okay, so the next thing that we're going to do is I'm going to go ahead and label my points, and I'm going to use t sub 1, and I'm going to use y sub 1 as my notation. So that's the first point. And the second point, I'm going to call that t sub 2, comma y sub 2. So the first step into writing this formula, there are 2 steps. The first one is to find the growth factor. And again, I'm saying growth factor here because we know the function is increasing, but basically you're solving for b. And then once you have the growth factor, then we'll find a, which is the initial value. So there's a general formula that you can use to find the growth factor, and that general formula is b raised to the t sub 2 minus t sub 1, I'm going to put that in parentheses to maintain order of operations, is equal to y sub 2 divided by y sub 1. Okay, so this is a formula that you want to memorize for finding b. Okay, so I would commit this to memory. And then now what we're going to do is we're going to just substitute in all the pieces. So b, and then raised to the t sub 2 is 2, minus t sub 1 is -1, is equal to 80 divided by 5/4. Okay, I'm going to just leave the fraction as is. I don't need to simplify it or anything right now. And so 2 minus -1 is 3, so that's b to the 3rd power is equal to 80 over 5/4. Okay, now the formula calls for just b, and so you can think of that as b to the 1st power, not b to the 3rd power. So how do I undo b to the 3rd power to get b to the 1st power? And the answer is we're going to take the cube root. So that's how you would undo that so that you end up with just b. So if you had something like b to the 4th power, so let's say if it was b to the 4th power, then you would take the 4th root to get it down to b, etc. Okay? All right. Let's go back and take the 3rd root. Okay, if you take the 3rd root on the left side of the equation, though, you have to also make sure that you take the cube root on the right side to keep this equation balanced. And so now it's just a matter of putting the cube root of 80 divided by 5/4 into your calculator. And the easiest way to take the cube root on your calculator is you can raise this, so the number 80 divided by 5/4. You can raise it to the 1/3 power. Okay, that's the same thing as taking the cube root. So again, if you had something like the 4th root of 80 over 5/4, right, that's the same thing as raising 80 divided by 5/4 to the 1/4 power, etc. Okay. All right, so let's finish this and put this into our calculator. Oops, let me go back to black here. And so if you put all of this into your calculator, I highly recommend that you put parentheses around that fraction to remain order of operations, and put parentheses around that entire exponent, 1/3, to maintain order of operations. And then we're going to find out that b is actually 4. So once we have the growth factor, our next step is to find a, which is the initial value. All right, so step 2, we're going to find a, which is the initial value. Okay, so how do we find a? Recall that in step 1, we found out that b was equal to 4. So to find the initial value, you're going to need b, which is what you found in step 1, and 1 point. So we have 2 points that lie on this curve, and you just need to choose 1 point. So I'm going to actually choose the point 2, 80, just because it's positive and we don't have to deal with the fraction. So I'm going to use the point 2, 80, where 2 represents t and 80 represents y, or you can think of that as f of t. So remember, the general equation for an exponential function is f of t is equal to a times b to the t. So we've got all the pieces that we can substitute into that equation. So I'm going to write that down again. F of t is equal to a times b to the t, and we can just substitute. So when f of t is 80, right, we don't know what a is, that's what we're trying to solve for, and b we found out was 4, and t is 2, okay, so when y is 80 and t is 2, notice that we have an equation here where we can now solve for a. So let's go ahead and do that. So I've got 80 on the left here is equal to a times 4 to the second power is 16. And then now let's just divide both sides by 16, and that's going to give us a. So 80 divided by 16, that gives us 5. So this tells us that the initial value is 5. Okay, so once you have all the pieces from step 1, b equals 4, and step 2, a equals 5, now we're the third step. We're just going to put it all together and write the equation. Okay, so final answer, the equation is f of t is equal to 5 times 4 to the t power. Now let's find the growth or decay rate. So to find the growth or decay rate, which is r, right, we're going to need to know what b is. And recall that in step 1, we found out that b is 4. So because our function is growing, we have b is a growth factor, which means we're going to find a growth rate, okay? And so to find this, remember, if you have a growth factor, the general equation for a growth factor is always 1 plus r. And so we're going to use that to help us find r, which is the rate. Okay, so all you have to do here is substitute. We know that b is 4, and now you have an equation where you can solve for r. So if we subtract 1 from both sides, that's going to give us r. So 3 is equal to r, and then we want it as a percent. So then now we take 3 and we multiply it by 100, and that gives us r as a percent. So r is 300%. So this tells us that our function is increasing by 300%. Now let's find the value of the function when x is 3. So what question B is asking is it's asking us to find f of 3. And recall that the equation that we found in the last part of this, in the first part of this video, was f of t is equal to 5 times 4 raised to the t power. So now we're just going to substitute in 3 for t, so that's 5 times 4 to the third power. And so f of 3 is equal to 320.